Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at how to write chemical formulas of ionic compounds or hydrates from their names. Now, in the previous lesson, we learned how to make ionic compound or actually write ionic compounds from a given set of ions. Okay, so now we are going to give you the name of a chemical formulas of ionic compounds or hydrate, and then we are going to write a chemical formula based on it. First of all, the first step is, of course, determine the formulas of the ions based on the name of the ions in the name of the formula. Just to illustrate here, we have aluminum and oxide. We know aluminum is in what group? It is in group 3A. So every element in group 3A has a charge of 3 plus. So we have Al 3 plus right there. Okay, and then for the oxide, that's coming from oxygen, and we know oxygen is in group 6A and it has the charge of 2 minus. Now you know why we spend so much time memorizing the monatomic ions as well as the polyatomic ions. So now we have 2 minus. Now if the charges are different, in this case we have 3 plus and 2 minus, they are different. They're not balanced. So we had to crisscross the number, only the number, okay? And when we talk about crisscross like this, that's what crisscross is. You just crisscross the number down, only the number. The way we do that, it's going to balance out the charges. And once the charges are balanced, we can cancel out. What does it really mean to cancel out? Well, the total number of positive charge is going to cancel out with the total number of negative charges. So if they are the same, now the charge is going to be, the net charge is going to be 0, or the overall charge is going to be 0. To illustrate that, okay, we're going to crisscross the number. I'm going to crisscross from the negative ions first because we are going to determine how many aluminum there are. So that number tells you the specific number of atoms for that opposite charges. So therefore, right here we have aluminum. That 2 right there, going to be 2 aluminum. And this is a subscript, okay? And we're going to do the same thing to oxygen. See how this 3 right there, only the number again, we crisscross, it represents the number of the ions on the opposite charge. So therefore, oxygen is O3. Isn't that easy? So to illustrate, each aluminum has, aluminum has 3 plus. If there are 2 of them, we have 2 3 plus, okay? And for oxygen, each one is 2 minus. So therefore, 2 minus, 2 minus, and give us a total of what? 6 minus. Over here, give a total of 6 plus, and that cancel out. Isn't that nice? And so this strategy works for every single ionic compounds. Now let's try sodium. Sodium is in group 1A, so we know it's going to be Na plus. Notice how I memorized the periodic table already. If you don't, you just look them up on the periodic table. In carbonate, we have a list of polyatomic ions for you already, which you already have on your notes. So in this case, carbonate is CO3 2 minus, CO3 2 minus. So notice how I write the ions with the charges on top. That's a superscript, and the subscript indicate how many there are in terms of specific element. So again, be very careful. We only crisscross the charges number. So that right there tell you there are 2 Na. But what about Na plus? Well, there's a 1 in front. When you see a minus or plus with nothing in front, we know it's going to be 1 because everything multiplied by 1 is equal to itself. So if that's the case, if it just only have 1, and we learned that when we have polyatomic ions, if there is only 1 of it, we don't have to use parentheses. So in this case, we just write CO3 without any parentheses because it's just 1, okay? So that's pretty easy so far. Now let's look at this one here. We have something called a hydrate, and a hydrate is basically a ionic compound surrounded by a specific number of water molecules. So hydrate, think of hydration, think of H2O, which is water. And when we have a hydrate, every single time we have a hydrate, there's a prefix right here that indicates the number of water molecules. And we have the prefix right here. These are numerical prefixes from 1 all the way to 10. So penta is what? Penta is 5. So 5 what? Hydrate, which is water. Okay, so what we are going to do is to illustrate the hydrate is attached to ionic compound. We are going to use, in most cases, it has a dot. That dot is basically a representation of an addition. Okay, so on your answer key, you are going to use this. So in this case, let's look at this. Copper is, what is this? Well, copper is not in group A, it's in group B. So for group B's, we use the Roman numeral to indicate the number of positive charges, right? So in this case, copper, that's easy. We don't even need to look at the periodic table. It's 2 plus. And sulfate is right here, SO4 2 minus. So sulfate is SO4 2 minus. Oh, look at that. The charge are the same, so we don't have to do any crisscross. So we just write down what they have. SO4. There you go. See? See, when the charges are the same, we don't have to do anything. Now, to write the hydrate, we are going to represent the dot right there and H2O, 5H2O. On your answer key, when you type on Streamline N, okay, you are going to use this copper sulfate. We are going to use the plus sign to indicate that 5 water molecules is added to it. So be careful with that, okay? So that's the limitation that we have. So this is what you are going to type online when we deal with hydrate. Now let's try another question with hydrate. Sodium is in group 1A, so that's easy. Na plus, carbonate, oh, we have that before. CO3 2 minus. And deca, what's deca? Deca is 10, so that's 10 hydrate, which is H2O. There you go. And we use this to represent the attachment of 10 water molecules. So crisscross. Sodium, again, just carry down the number, Na2. Well, 1 right there. So now we have CO3. Again, we don't need parentheses because there's only one of the polyatomic ions. And now we are going to write as a complete hydrate with a dot 10 H2O. If I'm going to type this online, it's going to be Na2 CO3 plus 10 H2O. Okay? Now let's try the last two questions. We have iron with a Roman numeral and a 3 in front. So therefore, we know that is in group B. So therefore, it's 3 plus. Isn't that nice? Easy. And for oxide, that's oxygen from group 6A. So it's O2 minus. And again, we crisscross only the number. So Fe, right? How many? 2. And then again, crisscross only the number. How many O do we have? Or in this case, how many oxide do we have? 2. And that's all it is. Now let's go to calcium. Calcium is in groups 2A, so it has Ca2 plus. See, you should be able to know the element on the periodic table and what group they are in by now. And then oxide, which is right here, OH minus. There you go. So we do the crisscross. What do we have? Well, there's nothing here, so we know it's 1. So it's going to be 1 calcium. So we don't write the 1, right? And then for the 2, we crisscross. And here we have 2 of OH. So what do we have to do? We have to put parentheses. There you go. And that's where the challenge is. When you have polyatomic ions, you have more than one of it. You have to use parentheses to group it. Because if I look at this, CaOH, right? This is not the same because right here we only have 2 hydrogen, but we have 1 oxygen. That's not what we're saying. We are saying that CaO2 H2, this is what equal to that, okay? So keep that in mind. That's the power of using parentheses. And as always, if you have any question about the problem on the videos or the practice, show your work and put it on the forum and we will do our best to help you from there. And we see you next time on another exciting chemistry lesson.